depending on where you're joining from. Welcome to the Data Platform Geeks webinar. Today we have Deepthi Anantharam from Microsoft who will be doing a session on Introduction to Cosmos DB. Before we start the webinar, I would like to quickly walk you through a few slides about Data Platform Geeks. Data Platform Geeks is a community initiative and a subsidiary of eDomino Systems, who have companies like SQLMaestros, Peopleware India, who specialize in training pan-India as well as online. Please do visit their sites to get more information. The fourth year of the conference, Data Platform Summit 2018, has been announced. This is happening from 9th to 11th of August, a 3-day conference, and there are also 2 pre-conference full-day trainings on 7th and 8th of August. The venue is Hotel Radisson Blu in Bengaluru, which used to be Hotel Park Plaza formerly. The conference is a 3-day pure learning event on data analytics and open source databases. And the 2 pre-conference training days are deep technical sessions, full day 8-hour trainings by specific trainers. So there are about 7 tracks, more than 100 sessions, and more than 50 speakers traveling from all around the world. We have data platform team members, the product team members, flying down from Redmond. We have Microsoft certified masters, MVPs, and industry experts who will be speaking at this conference. This is a 100% learning event, and you will get to listen to them as well as network with them and talk to the peers in your industry. Please do visit dps10.com for more information. I'll quickly introduce you to the core team behind Data Platform Geeks. Amit Bansal, the founder and president. Myself, I am Manohar Puna, I am the vice president. Avnish Panchal, Prince Rastogi, Sandeep Pani, and Surbhi Agarwal are the core team members and the pillars behind this Data Platform Geeks. eDomino teams, they help us run the events. A special thanks to Microsoft, who has been a very great support and helping us build this community and bring this conference to you. About the community, dataplatformgeeks.com. If you are attending this webinar today, you would have already registered on dataplatformgeeks.com. If you didn't got a chance to explore this site, please do visit, because there are a lot of free content available which will help you sharpen your skills as well as advance in your career. There are free videos, labs, and magazines, as well as a lot of blogs that are available on the site. Also, do join the largest SQL group on Facebook, the SQL Geeks. This is the official Facebook group of Data Platform Geeks, as well as the LinkedIn group. You can post questions and also take your time and answer some questions. This will help the community as well as get responses from the community. I would quickly hand over to Deepthi to start today's session. Over to you, Deepthi.
Thank you so much, Manohar. A warm welcome to everybody. Let me share my screen now. Let me know once you're able to see it.
Yes, Deepthi, we are able to see it.
Okay. My name is Deepthi, as he mentioned, as Manohar mentioned, and I've been working with Microsoft for 5 years. Technologies through my, we'll understand what and why of Cosmos. We'll understand what is the scale that it can support. So far, we've always been dealing with asset properties for consistency and saying things are consistent, but we are moving slightly away from that. There are different levels of consistency. So let's understand what that is and the multi-API support that it will give us. You could create a database along with me and explore a bit of graph. For those of you who have not done any graph databases, you could still give it a try after this, because it's going to be pretty simple if you keep along with me. So the definition of Cosmos, and I'm not referring to Cosmos database here, is that it is planet scale. That means it's a well-organized universe. So you have got large scale that it can handle. It can handle JSON data. It can it can take care of multi-API. And what do we mean by multi-API? Whether you want to write it with Mongo or Java, or if you're a SQL developer, want to use SQL, or if you want to use some kind of graph like Gremlin, it's possible to do it. And then you have, this is a NoSQL option. So why did we have to come out with something like a Cosmos, right? Let's look at the read and the write databases. We've always had one database for the primary database, we've had multiple secondaries, and depending on how far the secondaries are and depending upon the network speed, depending upon the other things, there would be a bit of latency. Now, so far when we said we give you an SLA on the databases, the SLA was always on availability alone. That means if the primary failed, the secondary could take over and run. Was there any database which really gave you much more than this, saying that we are going to give you performance guarantees at this level for reads and writes? And that is what we achieve with Cosmos DB. And how are we able to do that? Because you can create as many replicas as you want. It's not like a SQL Server always on scenario where you say there are 4 databases that I can support as a combination of primary and secondary in 2012. In later editions, it becomes 8 and so on. And these databases are not HA or DR databases. They are there for you to use them very, very actively as readable replicas. Does that mean it takes 2 minutes for something to sync from one geography to another? The answer is no. It's just an example here, right? We give you a different level of SLA for reads and writes, which we'll discuss eventually. So, eventual consistency means that you read the value as soon as it's committed from the primary database. Until the secondary receives the latest value, you keep reading what is new. Otherwise, you just read the latest value, right? This is also a good scenario to be in, because as soon as you make commitments, you would want to read and write that value. But for, let's say, a very strong application, a financial application, this wouldn't hold good. So what do? We take the strong consistency approach. So here we've got multiple databases. We've got the primary key P. We've got S1, S2, C1, C2 as the secondary databases. Okay, we've got S1 and S2 as the secondary databases, and C1 and C2 as the clients. So at 9 a.m., the value of a variable is A. At 10 a.m., it gets updated to B. If somebody tries to read the value of A from S2 database, they still get the value of A, though it has been written. At 10:10, if somebody tries to read, they still don't get the latest value. At 10:15, it gets back an acknowledgement that, S2 has been updated. Now, similarly, at 10:15, if you read, you will still get the same value of A. Either you read it from client 1 or from client 2 or from secondary database S1 or S2. In fact, even if you read it from primary database P, you would still get the value of A. And then at 10, you get one acknowledgement back, you get another acknowledgement back saying that everything has been updated. Once everything has been updated, then you read the same value of B from the primary and the secondary database 1 and the secondary database 2. So what happens? No matter what time you read and from where you read, you always get the same value. This is good. But if there are multiple replicas, here there's only S1 and S2, let's say you have 5 replicas, and it takes a little bit of a delay in doing this, in replicating the value across, then you don't get the latest value from there, right? So we have got 2 models. We've got an eventual model where you read different values, but it's available instantaneously when you update it from the primary database. And even the primary will not give you that value when you read until you get a commit from all the databases and all clients, right? So we've got, if you want high performance, right, then you use an eventual consistency. If you want high consistency, then you use a strong consistency. So it's a trade-off between the two. And we understand that you can't be either in eventual or strong, and something in between is needed, which is why there are 5 different consistency models that are supported: strong, bounded, session, prefix, and eventual. We've already discussed what is strong. So let's look at what is bounded, right? So you say primary has got a value of A at 11 o'clock. It gets updated, and then there is a staleness of 2 hours, right? You update the value of B at 12 o'clock. At 12:30, you read the value, you still get A. At 12:45, it commits back. After that, after the staleness exits, you will be able to read the same value from everywhere. So what does this actually mean? If the bounded staleness is 0, that means you are in strong consistency, right? So you're just saying that I might take 2 minutes to update. So give me a staleness of 2 minutes. Within the 2 minutes, if your secondary is not updated, the primary will still show the latest value. It's a use case to consider, right? Let's say for some reason your secondaries are broken, you wouldn't want the primary also to keep reflecting the old value after a particular amount of time. Like I mentioned before, if staleness is 0, then it becomes a strong consistency. So you define a time period and say, after this time period, show the latest values that you have. We've got one thing which is called the session consistency, right? User who commits sees the most recent data. For the rest of it, it's all eventual consistency. So when you write to one database, you'll be able to see the value latest from that one. And when it syncs, you'll be able to read from the other as well. Okay. Then we have the consistent prefix. The consistent prefix is important because let's say in the primary you write the value A and then update it to B and then to C and then to D. It will always sync in the same order and the client will be able to see it in the same order. Just to understand that it is not about atomicity, consistency, isolation, and durability. It's about how to maintain the consistency alone using these 5 different states. So between all of them, if you need high performance, you will have to use eventual. Somewhere in between is the sweet spot. Similarly, if you need high consistency, you will have to use strong. Otherwise, somewhere in between is the sweet spot. By default, when you create a model, it will be in session state. What do we mean by multi-API model? We've always had these differences, right? Do you write in T-SQL? Do you write in ANSI SQL? Do you write in PL SQL? What kind of languages do you use? Is there a database that can support everything and anything? And that is what multi-API model does. We understand that some of your data could be relational and you do a lot of SQL functions, you use the SQL API. Some of you would be migrating from Mongo or more used to Mongo, you have the Mongo APIs. We've got table APIs, we've got Cassandra APIs, and the number of APIs that we expose will just increase as we go along. We have got guaranteed low latency at 99th percentile. Okay, requests are served from so we've got a write consistency of less than 10 millisecond and a read latency of less than 5 millisecond. Like I mentioned, it's all the databases so far have been giving you 5 nines of availability, saying that it's going to be available. Nobody tells you in a guaranteed fashion. We give you guarantees on how fast you'll be able to read and write because of the way in which it is architected. One other thing that we need to consider is how would you scale storage and throughput? Now, this is true even for MySQL as a service, Postgre as a service, which are open source databases on Azure. We do not compel that when you increase the size of, let's say, capacity, that is the RU or the request units, you have to scale up the size as well and vice versa. Previously, what did you do? If you went from a 4-core machine to an 8-core machine, obviously the RAM on that machine would also be higher, though beyond a particular point you could control it. Now here you have got two areas. Either you choose a 10 GB database or you choose an unlimited database. Okay, and so that would take care of the storage, and the two can be independent. Even with a 10 GB database, you can have 1000 RUs, or even with a unlimited storage, you can have 400 RUs, which is like the compute units independent of each other. Let's actually go at this point in time and create a Cosmos DB and come back, right? This is the Azure portal, okay, a portal.azure.com. In case you don't have a subscription, please do sign up for a free subscription, which is going to give you 30 days of free trial or $150, however fast you consume them. I would go to create a resource and see what is popular is what you would have ticked, right? So if you go to databases, and in the databases, you will be able to see Cosmos, or you can just search for Cosmos and then you land at Azure Cosmos DB. So you give it a name. The way you'll be able to access it is ssgas demo2 documents.azure.com. Like I mentioned, you can choose what API to choose from over here. Whether it's SQL, Mongo, Cassandra, Azure Table, or Gremlin. Okay, you can choose what you would want to. At this point in time, since most of you would be new to graph databases, I will choose the Gremlin or the Graph APIs. Choose an appropriate subscription. For those of you who are not familiar with the term of resource group, please create a resource group henceforth going forward. A resource group is a logical container of all the resources that you would want. For example, if you want to do any role-based access control to, let's say, only the databases, you put all the databases in one resource group so that you just give access to that resource group and everybody has access. So there are different ways, right? Different strategies. You put all the web in one resource group, you put all the database in one resource group, or you say, this is my standard resource group, this is my development resource group, this is my production resource group, and so on. Currently, I'm going to use a resource group that's available. One other advantage of a resource group is if you delete the resource group, everything in the resource group will also get deleted. Why is this important? If you actually create a resource like a virtual machine, you may have to delete the virtual machine, the hard disk, the VNets, and so on and so forth, right? So it's never clean. It's not going to go away completely. But here, you know that what is it that you have in every resource group. Azure Cosmos DB is a first-class citizen. We have it in all the 50 regions that we are live in around the world right now. So I will pick up Southeast Asia, and pin my creation to dashboard. As you can see, there are a lot of automation options. So you don't have to come here and create a database every time. You could do PowerShell, CLI, and various other ways and means of scripting it. This should take about 15-20 seconds to come up with. So let's leave it at that. While this is getting deployed, the bell icon would go away. It says deployment in progress. It would say that it has finished successfully. So okay, we didn't scale anything at this point in time, which is what I wanted to show you. Okay, you can we will see how you can increase and decrease the size and increase and decrease the RUs once it is created as well. So what is this automatic indexing? We've dealt with different types of indexing. We've had primary indexes, foreign key indexes, we've had clustered indexes, we've got non-clustered indexes, we've got column store index, but we've got every column of the database gets indexed automatically in Cosmos DB. Okay. This is needed because we are guaranteeing you a read and write throughput. How will we do it if we don't know what data is there and where it is, right? So we automatically index every property of every record. In fact, for performance reasons, there are people who go down and turn off this default facility and only index a few columns because they say, I will never query it on the other columns. That is why we are able to support the multi-API because there is automatic indexing. When we say we give you a less than 10 millisecond write, it also means that we are indexing in that time as well. And the average time is like about 5-6 milliseconds. In about 5-6 milliseconds, it completes the write. So even if you're in a strong consistency and if you have multiple replicas, it will finish it on everything and even finish the indexing for you. It works well with every data model when we are automatically indexing it. It's latch free, the engines are optimized, and the index types are hash, range, and geospatial. It's highly optimized for write operations as well as read operations. This is something that I mentioned before, even in the last 15-20 minutes. When we are giving you an availability, okay, it's not an SLA only on being there for you to query. We are the first service to offer latency, to give you an SLA on latency, consistency, and throughput. So we are telling you how many compute units we'll give you. We'll tell you what consistency levels you're achieving, and we're promising guaranteed reads and writes. One of the benefits of having any service on Azure is that it goes with the security and the compliance that comes by default with Azure. Data is always encrypted at rest using AES 256 standard algorithms, and in motion using SSL. You have got row-level authorizations that come with it. You can include this in a network, and so everything is IP protected. Along with this, Cosmos DB is certified for ISO, for EUMC, HIPAA, PCI. PCI is the personal credit card information industry. SOC 1 and SOC 2 are more about the operations data. HIPAA is more about the healthcare industry. So there are all these certifications and much more, which eventually over a period of time Cosmos DB will attain. That means your data, Cosmos DB, can be used to store healthcare information, can be used to store personal information, including credit card information, and can be used for operationalization. GDPR is something that we are all working with and working towards, and I'm sure it's going to be pretty soon compliant. If there's any particular security that you're looking at or a compliance feature, do write to us on that. With all this coming out of the box, the total cost of ownership in comparison with our competitors like Mongo, Cassandra, or DynamoDB is still very, very little. Okay, and since this is so the cost is very little when compared to the others, as you could see over here. The other thing is it's fully managed as a service, so there is no DevOps expenses that's needed at all. So to summarize, what is Azure Cosmos DB? It has got a global distribution because it's available in 50 data centers across the world, and we are doubling our capacity and storage every 6 months, right? The number of regions. As the number of regions include, so would that. There's elastic scale out that you can do, increase and decrease in real time in a matter of milliseconds. We've got guaranteed latency, tunable consistency from the 5 different models that we spoke of, and comprehensive SLAs. How do we achieve all of this? We can use it for storing key value pair, column family, documents, and graphs. And this is achieved by using Azure Table, DocumentDB, or now called Cosmos DB, Mongo, and Gremlin. In the future, there will be many other APIs which will join the wing. So what is a graph database that we just created, right? When we said we took a graph database, there are nodes and there are edges and there are relationship between them. So when we created an RDBMS, or a relational database store, we always said a table A is related to table B. For example, a table of students is connected to a table of marks. A table of students is connected to a table of teachers. But how exactly are they connected? We could figure it out by using a bunch of keys, primary keys and foreign keys in play. Let's go to a more complex scenario like DNA, genome, and then you would see that it has to traverse along in a different way, and not everything can be tabular in nature. It will need this kind of visualization to understand how the relationships are between different entities. For example, let's try to see what is happening on social media. Who is related to who? What do people like? How do people, how do you get some kind of recommendations, right? For a search engine, it's based on your personality, what the current context is, what do you like, what's your age group, what products have you bought before. So any place where you care about relationships, you build a graph database. Okay, so what we're going to explore right now is Gremlin APIs with Tinkerpop. It would give you something like this, right? There are these students: Donald, Rita, Jim, Matt, John, Alice. Alice likes basketball. Virginia also likes it. Jim is studying business along with Virginia. Matt studies English along with Rita. Alice likes computer science along with Donald. Then there are people who are doing courses from this university. There are a bunch of people who like football. So you can see that anything that people know from when and how are represented best in a graph database. Let's go back to the graph database that we had built earlier, and as you can see that it's available now. Okay, it's the deployment has got succeeded. So let's go to the Gremlin console. Let me go to the Data Explorer instead. Okay, a quick tour for those of you who are not familiar with this activity. All of our Azure PaaS services, so there are two kinds, right? Infrastructure as a service, where we give you VMs which you can go and play around with, and platform as a service. All our PaaS services will capture all the activities that you would want to. Okay, Just give it a minute to refresh. Obviously on this one there won't be anything, but it will say on this subscription, on this resource group, what are the list of activities you have done, in what span of time, and in what categories: administrative, security, healthcare, alert, recommendation, and so on. You will be able to look at some of the settings like metrics. Okay, it will tell you what is the utilization of CPU, memory, the other metrics. Like for example, you may want to take a look at throughput. Okay, what is the throughput that you are getting from the database, what is the storage that you are using, what is the availability, latency, and so on. Right now it's a blank database, so let's do some activity and come back to this. Okay, so to do the activity, I'll go back to the data explorer. I will say I want to create a new graph. Okay, what is this database ID and what is this graph ID? A database is what it says. It's a database ID. Like you have a student database and a student table within that, right? So you use a database. I will call this SQLDB. Okay, SQLDB. Inside that, I will create something called as a person. Okay, a person is like a table. Now here, when you create, previously you created the environment. When you're creating the database, it's asking you if you want a fixed capacity or an unlimited capacity. Unfortunately, at this point in time, if you start with fixed, and if your data goes beyond that, you can't change to unlimited. So we would recommend that you go with unlimited if you're not doing a sample. Okay. When you go with fixed, we don't have to, we only ask you how many throughputs you want. Okay, you say I want more throughputs, and then you pay for the throughput that you want. There are people who go up to 30,000 throughput units and more. Okay, it's saying if you are, it gives you a thing, right? If you are using more than 10,000 RUs, go with unlimited storage. Now, if you, I wouldn't want that capacity. If you go with unlimited, it will ask you an additional thing. It will say, what is your partition key? A partition key will define on how your data is going to be sharded inside the database. Okay, and by default it has given 10,000. That's a recommendation, but you can go down. Okay, for the purposes of this demo, I'm going to go with fixed, and an ideal would be something like a 400. So I will create a 500 and say okay. That means I have created my first database. Within the database, I have created a collection called persons. When I open this persons, there is this graphical representation, a place where we can write gremlin queries. Okay, for the purposes of this execution, it's pretty simple. I have got certain queries written down, and we'll speak about it as we go along. So, okay, if you look at it, if you look at the results, why didn't say it executed? Why is this coming up with this weird name, right? I don't know if you can still read it, but it gives you a number, this 8BF, whatever you can see over here. So if you look at the, I'm just trying to arrange this a bit so that we can all see this better. Okay, what I added was, I wanted to add a person called Thomas Anderson at age 44. If you look at this, it said add a person, first name is Thomas and the last name is Anderson, age is 44, user ID is 1. Along with this, what is this that it has added? The ID and the label. Okay, there are certain additional things that a graph database adds, so it's able to index, it's able to do certain other things with it. Now I'll go and quickly add a few other users. We would want these users to be added. So like we had Thomas, we are going to execute the second one, which as you can see over here is Mary Anderson at age 39. Then we've got Robin Wakefield with a user ID of 3. There is no age for him. This is another beautiful property of any NoSQL database. You don't have to have consistent number of columns. He doesn't have a property called age. He doesn't have a property called age. It's as simple as that. So also the remaining two users like Ben White One of the reasons why you use it is to store JSON data. For example, let's say somebody buys 10 items, somebody buys 4 items, then you don't need, this is the best way to store it, right? Then you have another person called Ben Miller who does not have an age, and then you have Jack Connor who's got the age. Okay, now that we've got, let's just count. Okay, any information that you do will be available in the form of JSON. Like it's giving you a value of 5 since this was a count query. Otherwise, it gives you a graphical representation and a JSON representation. Now we are saying, let's say who is related to who, because anything which has a relationship is a good candidate for this, right? So we'll say Thomas add edge. Okay, let me explain the syntax to you, right? When we said add v, there are two properties here. One is an edge. Okay, one is an edge and the other is a vertex. These are all called vertices. Okay, like a person is a vertex, a course is a vertex, a university is a vertex. I like this person, I take this course, I play the sport. Anything which is like a line is called an edge. So far we kept creating these persons. Now we'll say we're going to add a vertex and we'll say Thomas knows Mary. Okay, it's pretty simple for you to understand. Thomas. Okay, so it's giving you a JSON output. Thomas knows another person called, and now if you look at the execution, right, it's using an ID, knows and edge is fine, and it's using another in vertex. So whatever query you are executing, it is storing that information and adding its own intelligence in real time. So one person was known to another. We've added one more thing where okay, I won't be able to know from here from the IDs, but Thomas knows Mary Kay. Thomas also knows Robin, and Robin knows Ben. This is interesting, right? Thomas knows Ben. All right, it's executed these queries. Now if I go back and say, you can also update a vertex. The reason why we have this query is because vertices were not updatable at one point in time in any NoSQL database. So if you want to change this person and say the age is 45, you are able to do this. If you want to change his age to 48, just go over here and execute. Now if you see what it is giving you, okay, do you remember that this person Thomas knew two other people? So it's showing how he's related to the other. If I click on this, it's also saying that this person is Mary Kay, her last name is Anderson, this is Robin Wakefield, okay, and the central person over here is Thomas Anderson, and he's related to both of them. So this is the way you would get a representation. If you want the same information in a JSON format, you get it in JSON format as well. Okay, now let's say query everybody who's got an age greater than 40. Okay, so it's giving you Thomas Anderson, it's giving you so there is only Thomas Anderson whose age is greater than 40. That's correct actually. Okay, so now we are saying whoever has age greater than 40, give their first name. Okay, and it says the person whose age is greater than 40 is Thomas. If I change this to greater than 30, we expect two people, Thomas and Mary Kay. If we say greater than 20, I think we should be getting all the four. Okay, yeah, since there were only two people with ages, okay, you've got that. Now who knows who, right? Who has the label Thomas and knows, okay, who? Let's run this query. Who all does Thomas know? This is the query. And Thomas knows Mary Kay Anderson. Now, here we are saying who does Thomas know and who does that person know. Okay, you're just going down multiple levels. Okay, now this person knows Ben Anderson, Robin Wakefield. So you get the value in this kind of a visualization showing who is related to who and how, and you also get the JSON format of it. If you want to query the same thing in a new SQL query, you could write SQL queries. When I say select star from C, it's actually giving me all the collections. Okay, a table is called a collection in a graph. So it's saying that when I say select query from it, it's giving me all the 5 people who are there, right? It's giving me Thomas, as you can see, with 48. Okay, slightly complex to scroll over here in this screen share. You have got Mary Kay Anderson, then you've got Robin Wakefield. You get the idea. So you can get this, you can run SQL like queries on this because we support it. You can upload any kind of a JSON statement you want to. Currently I did one after the other. You don't have to do this. You can upload it in one go by browsing from the local file and execute it. You can delete this graph, in which case I'll be deleting only this graph, or you can delete the entire database. Now let's go to the scale and settings. This is where we put, no, so here is where I said, you can't change this storage capacity from fixed to unlimited. That is not allowed. But you can change the throughput at any point in time. It does not even take too long to execute. Probably about 10 seconds or so, or less, it will finish executing. There is this concept of time to live, how long the query should live, and so on, which is slightly advanced. You can run stored procedures, you can run triggers, you can have user-defined functions inside Cosmos DB. This was like a basic overview of Cosmos DB. Let's come back again to see where it is used in real time. Okay. So integration of Cosmos DB with other Azure services are very, very important. Let's see an example, right? If you were logged into this webinar using Skype, how do you think we replicated so many times? If somebody is writing something, you're able to see that they are writing it. If you delete it off, they know that you have deleted it. Let's say there are 5 people chatting from 5 different countries in a group conversation. How do we know all of this? We use Graph API. So it integrates that. We use Cosmos DB, and Cosmos DB relates with Graph very well. There's a direct correlation. It supports one-on-one communication, group chats. It happens in real time. It tells you when somebody entered the conversation, when somebody left the conversation, because we use Cosmos DB for recording all this. Okay. Then there's this Toyota connected cars, which is a standard example where things come from an event hub. Then there's some HD inside streaming that happens. Then it gets stored into Cosmos DB as a use case and into the blob store. Okay, so why we are using it here is Cosmos can scale quite elastically, as we saw. To increase and decrease the number of RUs, it takes very little time. Then we have got this e-commerce challenger iStop spot, right? Basically, you use it for gaming scenarios. You use it in these scenarios where it is not very it's not very, where it is all write and read heavy. Okay. Now, let me just go back to my Data Explorer and look at some of the properties that's there. Okay. Now, we've been saying that you can replicate these databases. You can replicate these databases. How do you actually replicate? Okay. You pick up any region. I was in Southeast Asia. Let's say I want to replicate to Australia, or Australia East or Australia Southeast. You just go and click on this and a replication starts. It's not necessary that you have to have just I can do it in North Europe and South Brazil and South Central US and say save. Obviously, there would be data egress charges, but you can have as many things you want over here. Okay, and so it's updating at this point in time. It says the right regions is Southeast, and these are all the read regions you have. Okay, it had to finish updating before it will allow me to change the screen. So bear with me for a minute. But you saw that to set up replication globally or in multiple regions, all you have to do is go and click. Even when it is updating, this guy is available. So if you run a query from outside, you should be able to see it. Let's go to default consistency. Like we mentioned, strong is where you've got the maximum consistency. Eventual is where you've got the highest performancy. Just click on anything else that you want over here, and then you can say what is the lag. When you say bounded staleness alone, it will ask you. Remember, bounded staleness always comes with a definition of what is the lag. You can say that the lag can be so many seconds, so many hours, so many minutes, or if it is session, there's nothing you have to do. If it's consistent prefix, there's nothing you have to do. We leave it at session consistency for by default. For all security reasons, we have this firewall. Okay, whether you want to allow access from all network or from selected networks, you could give it a range of IP addresses. To manage the storage of this, you have got an URI. So if you want to access this anywhere, you use this ssgas demo2.documents.azure.com. 443 is the default port. You have primary and the secondary key and the connection strings. Most of the times, Cosmos DB gets added with a graph function. Okay, we've got something called as a function. You can write functions in C# or in Java. It listens to a change in the collection, and you can it integrates well with other things. So you could do some of these. You can see how you can add logs over here and the automation scripts. Okay. Last time when we saw the metrics, everything was being shown as 0, right? Now you see some numbers. Now you see some activity between 3:30 and 3:45, where the number of requests aggregated over 1 minute. Okay. Still, there's not some data to display. Let's look at what is the throughput we are getting. And what is the storage that we have used? Hardly anything. It's taking a minute or so to refresh because I'm looking at it for the last 1 hour, but you can look at it for the last 7 days as well. Let me just stop sharing my screen at this point in time to see what is the kind of questions or any questions or anything that you would want me to address. If that is the case, I will go on directly to those things. Otherwise, we can look at a few more properties. So I can see, Nirav, you have started asking a few questions. If you do it on the Q&A panel, it's much more easier for me to moderate it, and then I can understand. Okay. But yes, can we import data from other RDS like my MS SQL? The answer is no, because the data format itself is very, very different. There are ways and means by which you can script certain things and put it, but no, it's not like taking a back file or a DAC pack or a backpack file and restoring it. Just understand that the data itself is very, very different, right? So if you extract out all the data, you can add JSON tags to it in an Excel and then dump it in document DB. I hope you understand this. So let's say you have a table. Extract all the data, add the relevant JSON tags around it, and then you can import that JSON file. Any other questions, folks? Okay. Um, so the availability has been at 100%, not an issue over there. The latency is so 10 milliseconds is our SLA. The actual is down here. We are getting this information almost at 0 millisecond. Similarly, for the reads and for the writes, it's almost at the 0 millisecond. Okay, this is the reason for the slowness is that the data replication is in progress across multiple regions, but you get the idea of what all you could check when you have created a Cosmos DB. Manohar, would you want to make the mandatory, communications that you would want to, and then I'll take up any other further questions that they have.
Sure, Deepthi. Thank you. Please post your questions in the Q&A panel. While you post your questions, I have just a couple of slides to cover before Deepthi starts answering them. Let me share my screen. I would like to quickly walk you through the pre-conference training days that are available at the conference this year. We have 2 pre-conference training days, August 7th and August 8th, 6 on the first day and 6 on the second day. We have Troubleshoot and Optimize SQL Server Like a Pro by Dmitry Kotkovich, who is a Microsoft Certified Master from US. He's also a data platform MVP. We have Sunil Agarwal, who will be doing a full day training on how to migrate your on-premise database to Azure SQLDB as well as managed instance. Reza Rad, a very popular BI expert and MVP from New Zealand. He'll be doing a full day training on Power BI from rookie to rockstar. Dr. Leila Etati, who is a data scientist and an AI MVP from New Zealand again. She'll be doing 2 pre-conference trainings. The first one is on leading edge data science with Microsoft tools. Andy Leonard, a world-renowned BI expert, SIS expert. He'll be doing a full day of intelligent data integration with integration services as well as Azure Data Factory. The Cosmos DB full day workshop by Madan Gajendran and his team, the Cosmos DB team, is on 7th of August. On 8th of August, we have the second pre-con by Dr. Leila Tati. It's building intelligence applications using the Microsoft AI platform. If you're really serious about data science and R, this is a session for you. It's by world-renowned data science expert and Microsoft's MVP from UK, Steph Flocky. She'll be doing a full day training on practical R for everyone. Sanjay Mishra and his team, the Data Cat team, will be doing a full day training on how to build a scalable data architecture in Azure. Joey and Denny are coming back again this year. Joey will be doing a full day training on SQL Server Linux for the SQL Server DBA. Peter Myers, who has been a very popular speaker last year, he'll be doing a full day training on 0-2 analysis services. Denny Cherry will be doing a full day training on high availability and disaster recovery in SQL Server and Azure. For more information about these pre-cons and how to register, please visit dps10.com. And also, if you have any questions or if you need any help to talk to your manager or your company, please do write to us at contact@dps10.com, or you can reach us directly on the numbers here. This webinar is also recorded, so you can access this content and also go through the slides when you have chance. And I'll quickly hand over to Deepthi again to answer any questions.
Okay, thank you. Looks like a lot of interesting lineup of training content. We had one question in the meanwhile, which said, it's a follow-up of SQL Server. Can I import it from SQL to Cosmos? Where is this concept of edge and vertex inside SQL Server? So, SQL 2016-2017 also support graph queries. Okay, that is something for all of us to explore. Having said that, people who have been using graph databases before would be on some other databases like Neo4j and so on and so forth. So from there would be the concept of graphs and edges. SQL 2017-2016 do explore, or we'll have a separate session on graph databases inside SQL Server. Anything else?
Thank you, Deepthi. We don't have any more questions at this point. So I would also encourage, if you have any further questions, you can reach to Deepthi directly. She has her contact details in the slides. So, and also you can post your questions on the Facebook group. And there'll be a lot of sessions, interestingly, on Cosmos DB, because the Cosmos DB from Microsoft, Cosmos DB team from Microsoft will be at the conference. So this will be your best opportunity to interact with these people who actually make the product. Thanks again, Deepthi, for the wonderful session and taking out your time and doing this session for the community.
Thank you so much, folks. I look forward to your questions. Thank you.
Thank you, and have a great day.